expand on your question right here. This one is a positive x squared. The coefficient is positive, and we know that this is, it's kind of built like that quadratic stuff. Why? Because it's the x squared stuff, so I'm expecting a parabola, but I'm also expecting it to again, I'm saying pointing upwards like this, yeah. Okay, it's just, again, what does this 4 do to it? Because a parabola is going to be a nice little U in there. Well, let's find out with the nice table right here. See if I can set this up. I guess I only need 5 values, whatever. Okay, in any case, let me say, let's start with -2, -1, 0, 1, and 2. Then we'll see if we need that extra space right there. But again, these x values, they're just going straight into the equation. And I'm not using h of x just really for space purposes, although you're welcome to if you'd like. Let's start with y equals 4 plus x squared. But now our x we chose is -2 squared. And -2 times -2 is 4. That's positive 4. And 4 plus 4 is 8. So we get this ordered pair, -2, 8. Okay, so that's up here. And well, let's see the rest of this graph. Okay, so let's look at -1. What happens to this equation when x is -1? Y equals 4 plus, that'd be -1 squared. And -1 times -1 is 1. So 4 plus 1 is 5. Y equals 5. So we also have this ordered pair, -1, 5. All right, well, what about when x is 0? Well, then you get y equals 4 plus 0 times 0, which is 0 still. But y equals 4 plus 0 is 4. Okay, so we have this ordered pair 0, 4. Fair enough. How about when x is 1? That's positive 1. Y equals 4 plus 1 squared, 1 times 1, which is 1. And 4 plus 1 is 5. So we have this other ordered pair, 1, 5. Now you see this 5 how it repeated? That means that the tip of this thing, also known as a vertex, if you're wondering about that, would be this ordered pair right here. It's the y-intercept for us, okay? Now, is it always going to be the y-intercept? Not necessarily, depending on what they do to the equation. Let's keep going here. Let's look at when x is 2. So y equals 4 plus 2 times 2, which is 4. We've seen that already, right? 4 plus 4, that's going to be 8. So I don't need that. I don't need another point to make this graph work. I have my ordered pairs. I got -2, 8. And we also have that reflection as well, right? We got 2, 8 as well, right there. And then we had -1, 5. -1, 5, and also 1, 5. And then our last point at 0, 4, that's our y-intercept, okay? Now again, there should be some curvature here. I'm doing this by hand, so it may not be so obvious. But you should be able to see that between these two, like my red and purple point right here, the slope is different than it is between the purple and the green point. So even if you were just like, hey, look, I'm going to connect these with straight lines, like this, technically you'd be okay. But we want to be a little bit more accurate than that, even though I worry that my drawings make it worse. Here we go. Let's try it out. I'll use a black line this time. So, well, see me making it worse. That's okay. Yeah, that wasn't too bad for me. I'll take it. So, for canvas, again, you only need 2 points, and you'll have to choose that you want the parabola function in order to get this on the graph. But one of the points that you have to have is the, again, that's called the vertex, whether you want to call it a vertex, just the tip of the U. Well, how do we know that's the tip? Because it's right in the middle of these points. Even if you said, what number's right between, again, it's 5 and 5, but it's between because the x values are different. And then see the y values here? They're the same. So look at your x values, what number's in between. And since it's 0, it's corresponding y value. That tells us what the tip is right there.